All right, today we're going to figure out how we find the slope of a line passing through two different ordered pairs, and then we're going to talk about how we can describe what that slope means. So when we look at these problems and we see that we're looking for the slope of a line that's going through two ordered pairs, how do we figure that out, and then how do we describe what that slope might mean? In order to begin, it's going to be handy to know what slope actually is. So when we talk about slope, we should start with defining it, knowing the vocabulary. Slope actually describes what a line does. It describes a linear function. Okay, so the slope is a description of something. All right, so it's not a distance, it's not an ordered pair. It's a description of a line. It'll tell you what's happening, what it looks like. The slope itself is a rate of change, and it'll tell you how slanty a line goes, how steep it is, how far up does it go, how far down does it go. Maybe it doesn't go up or down at all. Maybe it doesn't go side to side at all. So slope is a rate of change. We have to understand what slope is before we begin to talk about finding out what it is. Okay, so when we go back to what we've originally done with Algebra 1 and previous things, a general definition for slope that I like to use, I call it rise over run. And I always stick with that definition for slope. Okay, and once again, it reminds me that this is not an ordered pair. It's not a distance. It's a way of describing a particular line. And when we talk about rise over run, we have to figure out, well, what does that mean? Rise, of course, being how far something goes up and down. Rise goes up and down. And then the run being how something goes from side to side. So when we think in terms of slope, we think of rise or run, going up and down over going side to side. When we talk about rate of change, though, we can figure out slope. There's another definition, a formula that I like to use just based off of, again, rise over run. Knowing what rate of change means, in mathematics we use the Greek letter delta to symbolize change. Okay, so delta means change. And when we talk about rise and the up and down, the axis that goes this way on the coordinate plane is the y-axis. So when we talk about rise, up and down, that is the change in the y-axis. Similarly, when we talk about the run, we're talking about going side to side, and the axis that does that is the x-axis. So when we think of slope, we're thinking of change in the y-axis over the change in the x-axis. Okay, and that is what we use to describe slope. Now, from the old days, right, we have a slope formula that will tell you, slope, which is abbreviated as the letter m, is y2 minus y1 over x2 minus x1. And a lot of people have memorized that definition for slope, and they continue to use that, which is fine. For me, I like to stick with change in y over the change in x. So when we look at the original problem and we see the two ordered pairs that we had were -2, 5 and 3, -10, how is it that we can find out what that slope is? And I will set it up two different ways. I will set it up my way, which I call my way, just using the change in y over the change in x. That way I can just work left to right. And then I will call it the old way or the formula way, where I use the slope formula that we've seen in the past. So if I do it my way, the reason why I choose this way is that for me it's simpler. I just like to work from left to right, So the change in the y-axis from left to right, the y-coordinates 5 and -10. So I'm just going to do 5, and then change means the difference of. So the difference of 5 and -10. Notice how careful we have to be with signs. The difference of 5 and -10, and then the change in x, the difference of -2 and 3. So I like to set things up that way. I like to work from left to right, and when I'm dealing with change over y, change over x, I can do it that way. If you're talking about the slope formula, you have y2, y1, x2, and x1. Well, which one's which? It's helpful to label things. You have x1, y1 here, and x2, y2 here. Basically your first x coordinate, your first y coordinate, your second x coordinate, your second y coordinate. That's what that means. And you can use the slope formula from the old days. So you have y2, which is -10, the minus from the formula, then y1, which is 5, and it's over, x2, which is 3, the minus from the formula, and then x1, which is negative 2. Once again, being careful with signs. And then for each case, we begin, to do some work. You have 5 minus negative 10, which is positive 15, negative 2 minus 3, which is negative 5, if you do it that way. And this way, you have negative 10 minus 5, which is negative 15, and 3 minus negative 2, positive 5. And so we have two different slopes, maybe. But the note is to always simplify slope. So always simplify slope. Maybe we have two different answers. It looks a little bit different, right? But in this case, we have a positive divided by a negative, which will be a negative. In this case, we have a negative divided by a positive, which will also be a negative. So in either case, our slope is negative 3. So in either way, the slope is negative 3. And since we always simplify it, we call it that. But now on to the second part of the question, which is how do we describe a slope of negative 3? Well, what are we going to do to describe a slope? Well, we have to recall, what is the definition of slope? And slope, again, is rise over run. And rise over run is a fraction, right? So if rise over run is a fraction, and our slope was negative 3, well, what is negative 3 as a fraction? It'll be negative 3 over 1. And now we have to work on the description. What does this mean? If we have a rise of negative 3, if rise is going up, but negative 3 means, negative going down, so the rise of negative 3 means, in fact, we're going down 3. That's what that means. It means we're going down 3. On the bottom, we have a run of positive 1. Run is side to side. Positive means going to the right, so a run of positive 1 means we're going to the right 1. So when I ask to describe what a slope of negative 3 means, what I'm actually asking students to do is tell me, what does this mean? Slope of negative 3 means we're moving down 3 and right 1 for each increment on that graph. So what does that graph look like? It looks like something that for every time I'm going down 3, I'm going right 1. Every time I'm going down 3, I'm going right 1. It's a line that kind of looks like that. And that's what slope will help you describe. So what about special cases, interesting cases? We look at the second and third problem from that work. The second example was like this. We had a point going through negative 2, negative 4, and 1, negative 4. Well, how would we work to find that slope, and then how would we describe it? So again, we can set up slope either way, change in y or the change in x, where I like to use from left to right. Some students like to use the slope formula, which is fine, doesn't matter either way. And whatever we get to, we're going to get either 0 over negative 3 or 0 over positive 3. And what do we do with that if we're always going to simplify slope? And we try using a calculator. Punch this stuff in a calculator. 0 divided by negative 3. 0 divided by 3. What your calculator will tell you is 0. That gives you the number 0. And you know what? You can point to 0 on a number line. It exists. 0 exists. You can point to it. So the slope of the line between these two ordered pairs exists. It is 0. But how would we describe a slope of 0? How would we describe a slope of 0? Well, again, slope is rise over run. We have a rise over a run. And if we look at both examples of the numbers we come up with, we have a 0 on the top. The rise is at the top. And what that means is we have 0 over some kind of run. So we have a rise of 0 over some kind of run. If a 0 is ever on the top, that means we have no rise. This thing is not rising. It's only running. And when you think about this, there's no rise. There's only a run. Well, what might that look like? It's not going up anywhere. It's just running. It's running side to side. It looks like this. You know what kind of line that is? That's a horizontal line. So how would we describe a slope of 0? Thinking of rise over run, we could come up with that there's no rise. It looks like this. That's a horizontal line. Now, if you don't believe me, just by looking at it, we can graph our two ordered pairs. If we sketch a quick graph of the two ordered pairs that we have, -2, -4. Here's -2. Here's -4. There's a point there. 1, -4. Here's 1. Here's -4 here. There's another point there. Those 2 points would make a horizontal line. Okay, so either way, you can come up with, if there's no rise, there's only a run, it's going to be a horizontal line. So if the slope is 0, no rise, only a run, a horizontal line. And that's what that would look like. Well, what about that third example? In the third example, we had different ordered pairs. Let's see what would happen with that. So we have an ordered pair at -5, 2, and an ordered pair at -5, 3. So we find our slope. Again, either way, you can do change in y over the change in x. I like to work from left to right. Or you can use the slope formula. And you'll find out. It doesn't matter which way you do it as long as you're doing it correctly. So if you work from left to right, you end up with -1 over 0. If you use the slope formula, you end up with +1 over 0. And now what do we do with that? If we're always going to simplify slope, what do we do with that? Go to the calculator. Punch these into a calculator. -1 divided by 0. 1 divided by 0. What's going to come up is an error. Error. So if we remember before, if we had 0, remember the question was, can you point to 0 on a number line? Absolutely you can. You can point to 0 on a number line. It exists. Can you point to error on a number line? Can you point to error on a number line? No, you cannot. So what does that mean for the slope? It means the slope is undefined. You can't point to it. It doesn't exist on a number line. So if we had the 0 on the top, our slope was 0. If we had the 0 on the bottom, our slope was undefined. So then we got to talk about what might that look like for the description. So how do we describe a slope that is undefined? And we can work the same way. Remember, slope is rise over run. But in this case, our 0 is at the bottom. And that means we have some kind of rise over 0 for a run. And if we have a 0 run, that means there is no run. We only have a rise. There is no run. So picture a graph that has only a rise but no run. It's not running side to side. It's just a rise. What does that look like? That looks like a vertical line. So when you are describing a slope that is undefined, you are describing a vertical line. And again, if you don't believe me, let's graph it. Let's graph these two ordered pairs, see what we would come up with. Okay, in the first ordered pair, we have -5, 2, -1, -2, -3, -4, -5, and then up 2. There's our point there. And then we have -5, 3. Here's -5, there was 2, so here's 3. -5, 3 is here. What kind of line does that make? That makes a vertical line. So if the slope is undefined, 0 at the bottom, we have a vertical line, and that's how you can describe it. Okay, so all through this chapter, all through this unit, we're going to have to know not only how to find slope, giving the number that goes with it, but also how to describe what that number means. Okay, so here was our first example again. We had to find the actual number. We simplify the answer, describe what it means. If we somehow turn up that the slope is 0, that's a horizontal line. If we turn out that the slope is undefined, that's a vertical line. And that's all for slope for today.